Hello everyone. In the previous video, we have studied about the definition of correlation, the types of correlation, like the simple, multiple correlation, partial correlation, linear, nonlinear correlation, and positive and negative correlation. And we have also studied about the method of measuring the correlation. They are basically the two methods through which we can calculate the correlation. One is the scatter diagram, and it is also known as a graphical representation, and other method is the algebraic method. In the algebraic method, there are the two methods through which we can calculate the correlation. One is the Karl-Pearson coefficient of correlation, and another is a Spearman-Lang correlation. So in this video, we'll study about the Karl-Pearson coefficient of correlation. The Karl-Pearson coefficient of correlation is denoted by small r. If we have the two variables x and y, then it is noted by rxy. The coefficient of correlation is also known as product moment correlation or a Pearson's correlation coefficient. The method, this is basically used to draw a line of best fit. Line of best fit is basically used to have an idea about the minimum possible errors. In the best fit, we have the minimum possible error between the data points, and it is a mathematical method of measuring the correlation between the two variables, and this is suggested by the Karl Pearson. This is the formula for calculating the Karl-Pearson coefficient of correlation, which is the covariance between x and y divided by the standard deviation of x and standard deviation of y. The other method is nothing but the simplification of this formula. Now, the interpretation of R. R is your coefficient of correlation. The coefficient of correlation lies between -1 to +1. And if your R is equals to +1, that indicates that we have a perfect positive correlation between the variables. Perfect positive correlation, that means the two variables are deviating in the same direction with the exact same percentage. And if your the coefficient of correlation is equals to -1, this indicates that the correlation between the two variables is in a opposite direction, and they are deviating with the same percentage but in the opposite direction. If your r is equals to 0, that means there is no relationship between the two variables. No relationship, that means there is no linear relationship between the two variables. The coefficient of correlation may measure the magnitude and also the direction. If your R is equals to positive 0.8, it indicates that your correlation is positive, and it is highly positive because the 0.8 is near to 1. It's close to 1. That is why it is known as high positive correlation. If your R is equals to minus 0.4, it is known as low degree of negative correlation because it is less than 0.5. Now, the assumption for the Karl-Pearson coefficient of correlation, in generally we have these three assumptions. First is like there should be a linear relationship between the two variables. In general, the correlation measure only the linear relationship between the two variables. And the other is like for a Pearson correlation, each variable should be continuous. That means we always have a continuous variable. If we have one or both of the variables are ordinal in measurement, then we use this Pearson-Lang correlation in place of Karl-Pearson coefficient of correlation. Now, the next assumption is we must have the equal number of observations. For example, that means if we have the 8 observation in the x variable, then we should have the 8 observation in the y variables. Then only we can find the correlation between these variables. Otherwise, we are not able to find the correlation. Now, the properties of correlation, one is like R lies between -1 and +1. It cannot exceed 1. If your value is greater than 1, that means you are not calculating it correctly. The correlation coefficient is independent of change of origin and scale. Change of origin and scale, that means if you are multiplying anything, multiplying or adding or subtracting with your R value, it doesn't affect. It will give the same value. Now the third one is independent variables are uncorrelated, but the converse is not true, because basically the correlation find the linear relationship between the variables. Now the merits and demerits. First merit is like it is quantitative figures which can be interpreted meaningfully. It helps to identify the absence or the presence of a relationship between the two variables. Now the demerit is one, if our observations are not linearly related, then we can't use the correlation coefficient. And compared to the other method, it is like a bit difficult for a non-mathematical person. The value of the coefficient is unduly affected by the extreme observations. So these are like the merits and demerits for the Karl-Pearson coefficient of correlation. Like the numerically, we can understand by using this question. We have the scores for the x and y. These are the scores. Now we wanted to calculate, is there any relationship between these scores? So we'll apply the coefficient of Karl-Pearson coefficient of correlation. We're using this formula where capital of N is the number of pairs of the scores. Summation of x and y are the sum of the product of the paired score. Summation of x indicates the sum of x scores, and summation of y indicates sum of y scores. Summation of x square is the square of the x square, and the summation of y is the sum of the squared y scores. Now what we do, we'll square the x observations and we'll square the y observations, and we multiply the observations of x and y together. Then we'll find the sum of these all columns. Then put the values in the formula. Then we'll find that the coefficient of correlation comes out to be minus 0.920. This indicates that there is a negative correlation between these scores of x and y, and it's a high negative correlation. High because 0.9 is very close to 1. So the interpretation is what? There is a high degree of negative correlation between the score of x and score of y.